Okay, looking at problem 4 on the 0608 document, we have a problem. Number 4 says n is 2, 3, 4, 5, 6, right?
Mm-hmm.
Okay, that means n takes value 2, okay? And then there are a bunch of questions, and you answer those questions for n equals 2, okay? Then n equals 3, and you answer the questions for n equals 3. And then n equals 4, and you answer the questions for n equals 4 as best you can. Okay? That makes sense? And maybe you made excellent progress on that one, but it's a little hard to read, and I knew the terminology would be difficult, but I wanted to wait until everybody was done with this before I talked about this. Okay? So, then we say, okay, we got a bullet here. Okay? We say, actually, it says for n equals 2, 3, 4, 5, 6 flips. Right? Because you're flipping that many coins.
Yeah.
You did 4 coin flips. You got a histogram, you got means, got standard deviations, and everybody did that right. Okay? So again, when you see this, you know you can't do 2 flips, 3 flips, 4 flips, up through 6 flips all at once, right? So it makes sense. Okay, first we do 2 flips. Okay? Then, okay, now n is 2. We've established that. For n, for 1, 2 through n, heads. Is that the way it's stated?
For which one?
Yeah.
Let me read my own question here. Yeah.
It's 0, 1.
Actually, it says how many ways. I'll write it as ways to get 1, 2, up through n heads, right? And what you're asked is how many ways are there to do it, right? Okay? So you're starting for n equals 2, so if n equals 2, tell it's getting late, I'm getting worse than usual. For 0, 1 up through n heads, right? If n equals 2, then it's just going to be 0, 1, or 2, right? Okay? Now, in a while, n is going to be 3, right? After you dispose of n equals 2, you're going to do n equals 3. Well, n equals 3 means you go from 0 up through 3 heads. So 0 heads, 1, 2, or 3, right? Okay? Then if n equals 4, it'd be 0, 1, 2, 3, or 4 heads. Make sense? Okay? Okay, so there's more. Let me see what else I'm asking here. Yeah, we're not going to worry about that just yet. I'm going to let you kind of worry about how to interpret that. Okay? Then I'll give you a few hints. Now, we got this, okay? Let's just do this much. Let's not worry about the next question. We can certainly do this question, hopefully. Maybe not, because you know, you've probably seen some of this, but that varies from one institution to another and 1 year to another. Okay, how many ways to get 0, 1 up through n heads? Okay, if n equals 2, that means the ways to get zero, 1, or 2 heads, right?
Mm-hmm.
Okay, so now, we've got a very specific situation. We've got 2 coins, right? And I'll even demonstrate. I've got a quarter and a dime, okay? I flip the quarter, I flip the dime. And I flip this one over in the back of this hand at the same time as I flip, oh man, I don't know how I'm going to do that. Okay, well, I'll just do this. Okay, now what are the possibilities for what I have here? What's one possibility? Got my right hand, I got my left hand. What's a possibility?
You could have
Heads in both.
Huh?
heads in both,
Heads in both?
tails in both,
Tails in both?
or one has
One of
one.
Or what?
One has one and one has the other.
One has one has the other. Are all those equally likely?
No.
Huh?
No.
No.
There's 2 situations where there could be 1 heads and 1 tails.
Yeah. Okay. Now, heads, tails is equally likely to tails, heads, right?
Mhm.
However, one of each isn't equally likely because it could be heads, tails. You know, what I just said was totally wrong. Heads, heads is equally likely with tails, tails, right? But then I kind of gave it away when I said heads, tails is equally likely with tails, heads, right? Okay? That make sense?
Yeah.
Okay, have you ever seen the tree diagram for this?
No.
We're seeing. Okay, so one way to do it is just with 2 coins and think about what's equally likely, okay? So you want to think about that a little more. Okay, so if you flip 1 coin, you're going to get heads or tails, right? Okay, well now we flip another coin. I'll use a different color here, although I don't think it's really necessary. Okay, now if your first coin is heads, well, your second coin could then be heads or tails with equally likelihood, right?
Mhm.
Because what your first coin does has no effect on what your second coin does.
Yeah.
Okay? And the same thing if your second coin is tails, right?
Yeah.
So, 50-50 chance your first coin is heads. If it is, there's a 50-50 chance your second coin will be heads, and a 50-50 chance your second coin will be tails, right?
Mhm.
And then similarly, if your first is tails, which is a 50-50 chance, there's a 50-50 chance you're going to get a heads on the second, 50-50 chance on this one, right? Meaning that all these outcomes are equally likely. Well, you know, your net outcome, if you do this, is heads and heads. This one is heads, tails. This one is tails, heads. And this one is tails, tails. Okay? Those are the equally likely outcomes. Now, how many of those give you no heads?
Oh, wait.
One.
Okay, well this is no heads, right?
Yeah.
How many of them give you 1 head?
Two.
Yeah. Oh, 1 head. And then 2 heads. 2 ways, right? I mean, 1 way. My eye catches the 2, and that's what goes into my voice. Getting late. Okay, so probability of getting 2 heads is what? 1 out of the 4 possibilities gives you 2 heads, right?
Yeah.
One head, there are 2 out of the 4 possibilities, right? And no heads, 1 out of 4, right?
I get it now.
Okay? Well, you know, we might pretty well know that because you've probably seen that. I mean, you know, I think that's often seen in 6th grade. But it's been a while, so you might not remember it, okay? I see a lot of smart people that don't remember what they did in 6th grade because it never gets reinforced. Curriculum needs to deal with that idea, but I'm not writing the curriculum and it's a good thing. Okay, so we could do a histogram, okay? Now the histogram I'm talking about is this. The number of heads is on this axis, 0, 1, or 2. Okay? And we're talking about, let's say, the number of ways, or we could be talking about the probability, right? There's 1 way to get this, 2 ways to get this, 1 way to get this, right? And the probability would be 1 out of 4, 2 out of 4, 1 out of 4. That makes sense? Is it halfway familiar? You seen it? Some of you? Yeah? Not sure. Okay. Well, think about it now. What happens if we add another flip? Because next, n is going to equal 3, right?
Mm-hmm.
Okay, so we've disposed of at least the first question for n equals 2, right? If all you get is the first question, I'll be happy with it. But if you can figure out subsequent questions, that's even better. Okay? Okay, well, see if you can work it out for n equals 3. And you could just extend this for another flip, right?
Mhm.
The tree diagram, or you can figure it out some other way.
Draw a tree diagram.